Lesson 2.2 brought to you by Lego Town Guy with Smirk and sunglasses. Looks like he's dressed for cold weather. So I told you in 2.1 that there were two concepts we're going to look at in this unit. Everything linear and everything exponential. Well, not everything, but a really good introduction to those two things. Well, we're going to take a short segue away from that and look at rates of change. Now, recall up here, things linear was constant addition, and things exponential was constant multiplication. So what we're going to take a look at is what happens when things are constantly added. So this is kind of a preview of what's to come with linear equations. So we're going to compute rates of change and then compared to ratios and conversion factors, see what's kind of similar and different between those. And we're going to interpret and use rates of change, which this is going to become really important a little bit later with our linear stuff. And then we're going to convert things using rates. So our author defines a rate of change. He means a rate that compares the change in one quantity to the change in another quantity. So for example, speed is a rate of change. It's the number of miles traveled divided by the number of hours it took to travel. We could do other kinds of rates like touchdowns per game. So the number of touchdowns per certain amount of games. You see this talked about in football. There's lots of commercials right now about if any team, I think it's DraftKings, if any team scores a touchdown in the Super Bowl, you get your money doubled if you bet. I would encourage you not to bet because you won't win, but whatever. Well, you might win. Who knows? Okay, so we get really specific when we talk about a unit rate, and that's something that has a denominator of 1. So let's just jump down right into question 4. I really like this question. And here we're told that, according to U.S. Census Bureau, about 2.7% of registered nurses in 1970 were men, compared to 9.6% in 2011. And then in 2011, the average salary was $60,700 per year for males and $51,100 for females. So let's start with how much did the percentage of male nurses increase from 1970 to 2011? So this is an actual change, or just the difference between the two values. So we're going to do the new minus old calculation, just like you did in project 1. That's 9.6 minus 2.7. So what is that value? Boy, I don't know off the top of my head. I really should, y'all, but I don't trust myself in these videos. So 9.6 minus 2.7 gets us, of course, 6.9. And let's be clear what this 6.9 is. This is a 6.9% increase in male nurses. Now, it isn't that it's just the units we're looking at are percentages. So then the second question I think is another really important question. That's how many years did it take for this change to occur? So this occurred, the new year currently is 2011. The year we started our data in was 1970. So this feels like a solid 41 years. So now we're going to create a rate. We're going to say, what was the change in percentage of male nurses in the field over this time period? So we're going to look at the 6.9, as our author tells us, 6.9% divided by 41 years. That's our rate. It's really important you include these units, especially because these percentages, we could calculate the relative change as a percent in this, which is a percent of a percent, which would be quite weird, right? So our answer tells us that well, let's go ahead and divide this and turn this into a unit rate. So I'm going to take that 6.9 and divide it by 41, and we get this approximately what, 0.168. Let's round it to that. So what is this? Well, remember, this is percents divided by years, but when we perform this division, we created the denominator as a 1. So what this tells us is that on average, over this 41 years, there was a 0.168% increase of males in the field of nursing per year since 1970. Why is it a rate of change? Because we're comparing the change in percentages to the change in years. All right, let's check out the second one. We're going to take the rate of pay for women compared to men in 2011. Now, notice the order these are written. So we're going to put the women dollars on top. So women nurses in 2011 were paid this. I'll put a W here so we know it's women. And then the men nurses were paid 60,700, and I will put an M there for men. And let's find this as a unit rate. Well, let's get a 1 in the denominator. Let's say that. So we're going to take the 51,100 divided by 60,700, and we get, let's round to the nearest cent, right? 0.84. Okay, so what is this telling us? Well, remember what this is. This is dollars earned by women divided by $1 earned by men. So what this tells us is women earned 84 cents for every dollar a male earned. Now, there might be there'll be some differences, right? Because this is the average annual salary for both of these. So there'll be some males that made more and some females that made more and some less. We'll talk about averages in Unit 4. But still, this is crazy. And it begs the question of why, which is what our author asks us to do. And it's a little scary, a little dangerous to jump into this in a math course because it's kind of a political and social issue. So what does it tell us about the gender gap in pay for nurses? Women earn 84 cents for every dollar a man earns. What's responsible? Well, yeah, great question. That's a dangerous one. If you looked at those percentages, it could be that if we want to attract male nurses to the field, we pay them more. But when you look at male-dominated fields, that gender pay gap also exists. So maybe there's something else going on in society. So why is number 7 not a rate of change? Well, we're not actually looking at the changes. We're not comparing changes in dollars. Let's say not comparing changes in women pay to men pay. It's just comparing in 1 year, that one snapshot. What's the difference between these two?